So we make it. Then we make holo in the watermelon in this form. So can you see the hole? So this is where the sugar will be placed. Then the whole content will be placed inside the water bath and left for some minutes so that we can experience the concentration moving from lower to higher concentration. So once the volume of water in this watermelon increases, that shows that the solution have moved from lower to higher concentration. Let's wait and see the next thing.
Wait.
Now, this particular measuring cylinder will use it to measure the level of the water before leaving it for a while. I think the level of the water, sugar solution in the watermelon is that's 9. So it will rise after some few minutes, like 45 minutes. See that the level of water in the water bath is at this level, so which rises above the sugar solution in the watermelon. So after some minutes, the level of this water will reduce while the sugar solution in the watermelon will rises. So that shows that molecules has moved from what? From this lower solution to what? Higher concentration. So the sugar solution is the higher concentration, and the water in the water bath is the lower solution. So once it enter into this, you will notice that by reduction or decrease in the volume of this. You can see the mark. So at this inside the watermelon, the sugar solution will rises while this will reduce. That which confirm from beginning.
What do you want to do?
From what we have on the board, so we are demonstrating osmosis using a living tissue, and our living tissue, as I've said earlier, is watermelon. So we know the aim. Our aim is usually to demonstrate osmosis using a living tissue. What's our living tissue? Watermelon. So the watermelon has been peeled, and the sugar solution is one of the material. Then water bath with water as well. So the method is as follows. So just study it, then we'll look at the observation. What we are going to observe are these. The level of the sugar solution in the watermelon will increase, as I've said earlier, and the level of water in the water bath decreases. So this is showing that molecule move from water bath to watermelon containing sugar solution. In conclusion, this shows that osmosis takes place in a living tissue. Now, one thing that we need to note that will make our experiment to be faster compared to when you use yam or pawpaw is that watermelon has a high permeability to allow water to enter into it faster than all those ones, because they are highly permeable. Are we together? So this will make our experiment to be faster compared to when you use yam and pawpaw, so which will take like 4 hours before you can observe anything. To start test of food test, we are starting with carbohydrate food. We have here bread, and we also have here rice. Now the reagent we are going to use to test for that is iodine solution, which is this. So this solution will be added to what? To the food, to the food material we have here. So which will give us the result. So we are going to have our color. The color of iodine will change to blue black. So you see. So that confirms that this food item is what? Is a carbohydrate food or starch. Let's also check the second one, which is bread. So you can also see that this also changed to what? To dark or blue black. If you want to check it closer, you see. All depends on what? On the amount of iodine solution you put on it. This is egg, and we know egg to be a what? A food material which belongs to what class of food? Protein. Now, the actual part of the egg that has the protein is the what? White paste. We are not going to take the yolk. So what we need is what? Is the water. So just take little amount of that. Alright, we have the white paste here. Now, the next. These are the reagents we are going to use to confirm if these food items inside this test tube is a proteinous material. Now, the first one is sodium hydroxide, while the second one is copper 2 sulfate. So both together they are referred as a burette what? Reagent. Both are referred as what? Burette what? Reagent. So if you are asked to list or name burette reagent, the first one is what? Sodium hydroxide. The second one is what? Copper 2 sulfate. Do you understand? Now, these two are what give us what? Burette reagents. So let's add them one after the other. The first one you add is you add your sodium hydroxide in drop. Followed by so the quantity you are adding, can you see reaction occurring? Can you see? Do you notice any changes?
Yes.
Changes at the center. So by the time you shake thoroughly, you have what color? What color are you expecting? You have purple. So because the content is not much, so now you can see that confirms that this food material is what? Is a proteinous food. That is that. This is what? Granite, and is a food material. Now, we want to confirm the class of food it belongs to. So this is filter paper. What do I call it? Filter paper. Looking at this filter paper through the light, you see that it's not what? Translucent. Light does not pass it through. Now, what do? this we grind the groundnut on it. So we can see the circle. That circle is the area where the groundnut was smelled, and after it we discover that there is a what transparent, that the light can pass through the what that particular portion, while this other portion they are not transparent. So that confirms that this particular food item has what fat and oil content. That is it.